Hey guys, so here we have a MIG gun. This one specifically is called a spool gun. This one has the wire on the gun itself, so it actually spins it off the gun into your workpiece. But there's different ones, such as this one. This one's called a push-pull gun. It has the same thing, it's just a little different. It gets the wire from the machine itself and putting it onto your workpiece, but overall it does the same thing. Here we have our little setup with our gas and our welding machine. We actually are using a Power MIG 256 Lincoln, and here are all the knobs where you can change your settings, your wire speed, your voltage. You just put it how you want it. Here is our gas tank. We are actually using argon and CO2. It's 25% to 75%. On here we have a different supply for your gas. You can see we have different kinds of gases. For this one we'll be using argon and CO2. And this is our little setup, our table. We got our vent machine and our light. And this is our little table where we do our tests.
Hey, you guys, it's me, Robert from class. I'm here to tell you about some key techniques for MIG aluminum.
First and foremost, key technique. Well, I don't know if you would consider this a technique, but prep your material before doing any welding. Because now you're dealing with aluminum, and to get the cleanest bead, you need to clean that surface of any contaminants. Also, don't forget to wear your proper protection, cause when you're welding aluminum, it tends to get really hot, cause I did it, and I was wearing my arm sleeves, but nothing covering my shirt, which was exposed, and it burned through my shirt, which also left splatter and slight burn marks on my shoulder. Another key to welding aluminum in MIG is make sure everything in your positioning is good to go before you start, which would be the travel angle and work angle, so that way your bead comes out nice and consistent, unlike mine. As you can see in the video, I tried attempting 3G, but overall, for being my first time, I like to think I did pretty good. Another side note also is make sure nothing else is in your way, because I forgot to move my C-clamp out the way.
MIG welding aluminum can be a bit tricky compared to steel due to aluminum's unique properties, such as its thermal conductivity and oxide layer. Here are some key techniques to ensure a successful MIG weld on aluminum. 1. Clean the aluminum. Remove oxide layer. Aluminum forms a protective oxide layer that needs to be removed. Use a stainless steel wire brush, chemical cleaner, or abrasive pad to clean the surface just before welding. Ensure cleanliness. The base metal and filler material must be free of oils, dirt, and other contaminants. 2. Use the right filler material. Select appropriate filler rod. Common filler alloys for aluminum include 4045, 4047, and 5356. Choose the filler material that matches the base aluminum alloy you're working with. 3. Choose the right gas. Shielding gas. Use 100% argon as the shielding gas. Argon provides good protection and produces a clean weld with minimal spatter. 4. Use the correct nozzle and contact tip. Nozzle. Use a larger diameter nozzle to accommodate the larger aluminum wire and to provide better shielding gas coverage. Contact tip. Ensure the contact tip is the correct size for the aluminum wire you're using. Tips for aluminum are often made of a different material than those for steel to prevent buildup and ensure smooth feeding. 5. Control heat input. Heat management. Aluminum conducts heat very well, so managing heat input is crucial. Avoid overheating, which can cause warping or burn-through. 6. Practice proper technique. Stringer beads and weave patterns. For flat or horizontal positions, use a stringer bead technique or a slight weave to ensure good fusion and appearance. 7. Consider using push technique. Push technique. Push the torch rather than dragging it. Pushing helps to ensure that the molten weld pool is well shielded by the gas. 8. Regular maintenance of equipment. Clean equipment. Regularly clean the contact tip, nozzle, and liner to prevent any blockages or issues with wire feeding.